During the last class, we were discussing about the for statement or the for loop, also known as the for loop. In order to repeat a block of code, we use the for statement, and the number of repetitions or how many times it is to be repeated, that can be controlled using the for loop that we have seen in the previous class. Now, that was the simplest form of for loop that we were discussed in the previous class. In today's class, we will discuss a bit more complex forms of the for statement. Like the for loop is a very flexible construct. Actually, it is a very flexible statement or flexible loop. Flexible loop in the sense that we can use decrementing counter instead of the incrementing. We used the incrementing counter in the previous session or previous class, and actually we can use the decrementing also. I mean, decrementing counter is also can also be used in instead of the incrementing counter. As an example, for this statement is an example. This one, for n count equal to 100, n count greater than 0, n count minus minus. So what it starts is the for loop. You know that for loop starts with an initialization, then a condition, then and then increment. So that is the three statements that is necessary inside a for loop, and all these three conditions or three statements are separated by semicolons. So the last statement, that is after the increment statement, there is no semicolon present. So n count equal to 100. N count is initialized as 100. The variable in this case, the variable which changes its value in this for loop is n count. So n count is 100 in this case. The initialized n count is initialized as 100. Then n count is greater than 0. The condition that is checking is whether n count is greater than 0 or not. If n count is greater than 0, then obviously whatever is within this for loop, that is the block of code that is within for loop, will be run. Then n count minus minus. So we are decrementing the value of n count. So initially it is 100, then we are decrementing it. So it becomes 99, 98, 97, etc. So that it becomes decreased. Normally, what we have seen in the previous session was about incrementing the variable that is inside the for loop. But here we are decrementing the variable inside the for loop. So then other way of using for is we can use a counter which is other than 1. We have till now seen that it is incremented as well as decremented using the increment operator as well as the decrement operator. While using the increment operator, 1 is added to that particular variable, and while decrementing the this thing, or while using the decrement operator, 1 is subtracted from the variable. But the counter can be any value, that is any value which is an integer value, that is it can be greater than 1 also, or it can be less than 1 also, no problem, like this. So here in this for loop, n count is equal to 0, n count is initialized as 0, then n count is less than 1000. So the condition that is checking is n count is less than 1000 or not. So when n count is less than 1000, this code will be running. Then n count plus equal to 3. So that is here, this statement, this increment operator, this gives you an increment or a stepwise increment of 3, n count equal to n count plus 3. That is this statement. You know that this statement is a compound assignment statement, that is n count plus equal to 3 is a compound assignment. So this is a compound assignment operator which assigns a value which is added to, that is a 3 is a value in which 3 is added to the current value of n count to n count. That is n count is assigned with n count plus 3. So that is it, n count equal to n count plus 3. So this is the meaning of this statement that we have already said. So in all the cases, 3 will be added to n count. So a step of 3 is assigned in this case. Then initial value can be omitted if the test variable has been initialized beforehand. That is also possible. That is, this particular statement can be avoided. This n count equal to 0. That can be avoided if it has already been initialized. So, but still the semicolon should be there. That is an example. See, this is an example. In this example, this n count is initialized as 1. Before the for loop itself, n count is initialized as 1. Then we start the for loop 4. Then it starts with a semicolon because the initialization is not required. Initialization is already done. N count is equal to 1. That is, initialization is already done. So 4 semicolon. So after this n count equal to 1, you need a semicolon here like this. And after the initialization of the variable, you need a semicolon here. So that semicolon is put here also. So n count equal to 1, then n count is less than 1000, n count plus plus. This one is similar to this statement. Okay, this is similar to this statement. The only difference is that n count is initialized as 1 in this case. Initially it is given a value of 1 and then it is used inside the for loop. So for loop, then for, we start the brackets, then we put a semicolon. This semicolon is here. Actually, this is to be put in this place. In this place, actually, the n count equal to 1 is to be put. But since it is already initialized as 1, we don't have to put it here. Then n count is less than or equal to less than 1000. We are checking whether n count is less than 1000. If n count is less than 1000, then whatever is inside this block of code, that is to be executed. Then n count plus plus. So the initial value can be any valid C expression. The expression is executed once when the for statement is first reached. For example, so that is the initial value. The initial execution can be any valid C expression. It need not be exactly the initialization of the particular value. It can be any C expression or C statement. So that particular expression is executed only once when the for statement is first reached. Example, as an example, C n count equal to 1, that is initialized here. Then we go to the for. Inside the for, it is printf, now sorting the array. So this will be printed as the initialization. So here already n count is initialized as 1. So you don't have to initialize it again here. Instead, you are giving only a statement that is now sorting the array. That particular statement is to be displayed on the screen. So that is why this printf now sorting the array, that it will be displayed. Then the semicolon, then n count is less than 1000, n count plus plus. So the remaining things will be the block of code that is to be executed. So the increment or decrement expression can be omitted as long as the counter variable is updated within the body of the for statement. This condition, this increment or decrement, this can also be omitted if an increment is done inside the code itself, inside the body of the for statement, or inside the block of code that is being executed inside the for loop. So, but still the semicolon must be included. As an example, for n count equal to 0, n count less than 100, semicolon, then here the increment had to be there. The increment is supposed to be here. But what happens is inside the printf statement, after this for loop, we insert a printf statement. So inside the printf statement, the n count is increased. N count is increased by 1. That is n count plus plus. So n count is increased by 1. So that particular value is displayed also. So in this case, what this particular program does is from 0 to 100 or 0 to 99 actually, because n count is less than 100. So up to 99, the values are displayed in this printf statement, using this printf statement. So since this n count is increased here, The increment is of the n count is done inside this particular statement, that is n count plus plus. You don't have to insert it again here. You don't have to insert it right here. You can insert it only once. The condition expression that terminates the loop can be any valid C expression. You see that there is a condition expression. After the initialization, there is a condition, then the increment or decrement. So this condition statement can be again any valid condition statement inside SC, inside the C programming. The only thing is that it has to be either evaluated to true or it has to be either evaluated to false. That is, it should be the result of this particular expression should be a binary value or a Boolean value, whether it can be either 0 or a non-zero. It can be either true or a false. So as long as it evaluates as true, that is a non-zero, the for statement continues to execute. That is it. This statement, if n count is less than 1000 and ampersand, that is AND, the logical and the name n count is not equal to 0, the name n count is not equal to 0. So in that case, if it is evaluated to be true, if it is evaluated to be true, then whatever is inside this particular for loop, that will be executed. That is printf %d name n count, that will be displayed. That is the integer value that is stored inside the array name is displayed. So this is actually this name and count. This is actually an array that about the array we will study later. So the another statement is for n count equal to 0, n count less than 1000 and list n count. So see here this increment operator is missing. So that increment operator is listed here, or that is inserted here, n count plus plus, that is inserted here. So this way we can create a variety of ways in which the for loop can be used. So in the condition statement inside the for loop, you can use any logical operators in order to construct more complex condition expressions. The next is the for statement can be followed by a null or empty statement, so that task is done inside the for loop only. So a null statement consists of a semicolon alone on a line. For example, so here for count equal to 0, count less than 20,000, count plus plus. So what it does is it has to count from 0 to 19,999, and then we are putting only a semicolon here. Semicolon means there is a null statement, that is null statement is to be executed. So what this particular statement actually does is that it does nothing visible, but what it does is it waits for 20,000 milliseconds, that is 20 seconds. It waits for 20 seconds. Why it is 20 seconds? Because it counts from, the program counts from 0 to 20,000 or 19,999. So in order to count from this particular 0 limit to this 19,999, the system requires 20 seconds or 20,000 milliseconds. So that is one number is counted in a millisecond. So there is another option also, that is an expression can be created by separating two sub-expressions with the comma operator and are evaluated in left to right order, and the entire expression evaluates to the value of the right sub-expression. So let us see how this can be done. That is, more than one expression can be inserted inside the for loop. That is the condition. So each part of the for statement can be made to perform multiple duties. For example, so the same for loop can be used in order to perform multiple duties. Like we have two arrays with 1,000 elements each, named A and B. That is, there are two array of elements which are named as A and B. Then we want to copy the contents of A to B in the reverse order. So after the copy operation, the array content should be, so this B0, B1 and B2. Those values will be taking the values of A999, A998, A997 and so on. So that is 0, 1, 2, 3. If it is 0, 1, 2, 3, 4, etc., it should be transferred to 999, 998, 997, 996, 995, etc. So this goes on. So how this can be done? So the sample coding for doing this condition is here. See, for I row equal to 0, j column equal to 999. See, here two expressions are inserted together, like I row equal to 0 as well as j column equal to 999, with a separating comma in between these two statements. So two statements can be incorporated together inside a for loop. No problem. This is two initialization statements. Two initialization statements are inserted together. Then I row is less than 1,000. So since the semicolon is present, it is only a single statement or single condition checking is there. That is, I row is less than 1,000. Then I row plus plus and j column minus minus. So I row, that value will be incremented as well as j column will be decremented. So what happens is when B j column equal to A I row, when this one is given, B j column means B 999, B 999 equal to A I row, that is A0. When I row is increased, that is when I row becomes 1, j column becomes 998. When I row becomes 2, this becomes 997. So see this mapping, 1 is corresponding to 998, 2 is corresponding to 997, 3 corresponding to 996, etc. etc. So this way we can use more than one statements or more than one initialization as well as increment operators, increment variables inside the same for loop. So this can be used in order to do complex programming also. That is, otherwise, if we are not using a for loop like this, we must be using two for loops. That is, a for loop inside another for loop in order to do this particular operation. That is, transferring the variables, transferring the values that is inside a row in a reverse order into another row. So another examples of the for statements gives something like this, like n sum equal to 0. That is, the initialization is n sum. Initialization of n sum equal to 0. Then the for loop starts. I row equal to 1. So I row is initialized to 1. I row less than or equal to 20. I row plus plus. So this is the normal for loop statement or for loop starting, the starting of a normal for loop. So I row is initialized as 1, then I row is checked whether it is less than or equal to 20, then I row is incremented. So then what we do is we sum up n sum equal to n sum plus I row. That is, the value of I row is added to the n sum variable. N sum is the sum of all the values, all the integers from 0 to 20 will be there. So printf sum of the first 20 natural numbers. So the sum of the first 20 natural numbers we will be getting here, getting as n sum. We will be getting n sum as the sum of the first 20 natural numbers. So the above program segment will compute and display the sum of the first 20 natural numbers. The above example can be rewritten as. So this example can be rewritten as for I num equal to 1 instead of I row. Instead of I row, we are using I num, and n sum equal to 0. N sum is the same as n sum here. So both these statements are put together. Both these statements are put together. Then inum is less than or equal to 20, inum plus plus. So that is the same as this one. So here what we are doing is we are putting this n sum equal to 0 to here, and then the rest is being done. Then n sum equal to n sum plus inum. So that is the same as this one. Then print the sum of the first 20 natural numbers percentage d n sum. So take note that the initialization part has two statements separated by a comma. See here, this particular initialization statement has two different variables or two different statements, and each one is separated by a comma. Another example of the for loop is or the complex for loop. We can call it as a complex for loop. For inum equal to 2, n sum equal to 0, n sum 2 equal to 0. So that is, there is a variable inum which is initialized to 2, then a comma, n sum equal to 0. That is the first. Another variable that is initialized to 0. Then a third variable, n sum 2, that is also initialized to 0. So there are three variables in this particular for loop. Then inum is less than or equal to 20. So this is the condition checking whether inum is less than or equal to 20. Then inum equal to inum plus 2. Then it gives you inum equal to inum plus 2. That is, inum is increased by 2 in each step. Sorry. Then what we does is the n sum. The n sum is initially 0. Then it is added with n sum is initially added with inum. So here initially inum is 2. Then in the first loop inum equal to 2. Then inum is added to n sum. So n sum equal to 2 initially. Then in the next iteration inum becomes 4 because inum equal to inum plus 2. So inum becomes 4. So n sum equal to n sum plus inum. So n sum is now 2. 2 plus the inum is 4. Plus next iteration, it will be 6. So it will be 6, then 8, then plus 10, plus 12, etc. So up to, it goes up to 20. It goes up to 20. So then in the next statement, here what it happens is that n sum 2. N sum 2 is initialized with a value of 0 here. N sum 2 is initialized with a value of 0 here. So n sum 2 equal to 0 plus, initially 0 plus inum into inum. So inum is initially 2. So 2 into 2, that is 4. So this is 4. N sum 2 is initialized as 4. For the first value, that n sum 2 will get is 4. Then the next value will be 4 plus 4 into 4. So this is 4 into 4 is 16, 16 plus 4 is 20. So that will be 20. So what it happens is 4, then 16, then 36, etc. So these values are inserted or added together. So that is the square of each even number. Square of each even number is added together here. Here, the squares of the even numbers are added together. So first what we will print is sum of the even natural numbers up to 20. We find out the sum of the even natural numbers up to 20. That is the n sum. N sum is the first 20. Sum of the even natural numbers up to the value 20 is added together. Then sum of the square for the even natural numbers up to 20. Square of these numbers is then found out in the next line. So in this example, the for statement is a compound or a block statement. So it is a compound statement. See here, there is a number of statements. So note that the initial value in the initialization part doesn't have to be 0, and the increment value unnecessarily need to be 1. So that is always the initialization need not be equal to 0. So in this case, two values are initialized to 0 and one value is initialized to 2. So that is also possible. That is, we can initialize to any value. In the previous case, in one of the previous cases, we have seen that the initial value is the variable is initialized to 100. So that is also possible. Then another condition is the increment need not be always 1. It can be 2, 3, or any value is possible. So we can also, using a for loop, we can also use an infinite or never-ending loop by omitting all expressions or by using a non-zero constant for condition as shown in the following two code snippets. See, inside this for, only the for and brackets and within brackets 2 semicolons are given. So what happens is there is no initialization, there is no condition checking, there is no increment. So what happens is that this loop, this for loop will continue or will be running infinitely. That is, it won't terminate at a specified time. It won't terminate. Instead of terminating it, it will continue to run on its own. So then another option is for, then within brackets semicolon 1 and semicolon. So that is it. Here also the condition instead of the condition only 1 is given. Instead of the initialization, blank is given. So no variable is initialized. Instead of the condition checking for the variable, what it gives is it gives only a single number. Then the increment is also not done here. So this also creates a never-ending loop. So printf, this is an infinite loop. So that is it. So in both cases, the message this is an infinite loop will be printed repeatedly and indefinitely. So another option for this for loop is this for loop can be nested to any degree. That is, here is a for loop. So inside this for loop, there is a possibility of another for loop, and inside this one, another for loop is possible. So likewise, up to any level, the for loop can go, whether it is 9, 10, 100, or that many number of nested for loops is possible. Normally, in the case of our matrix operations, we mostly need at least three levels of for nested loops. So now let's see an example in which the nested loop is inserted and nested loop is used. So here, this is this particular program employs a nested for loop. Nested for loop only up to 2 levels it is given. That is, only 2 outer loop as well as inner loop is there. So the values, the integer values, the integer variables that is declared are n, I, and j. So then initially what the computer takes or the program takes is it takes in the value of n, that is printf enter the value of n. So that is the value of n is to be input by the user, by the programmer. Then scanf %d(n). So n is then taken in, that is the user inputs this value of n and the computer or the program reads that particular value. So the reading is done using this particular statement, that is scanf %d(n). Then what we do is we go to the first for loop, the outer for loop. We go to the outer for loop, and inside the outer for loop, I equal to 1. So I is already defined here. So I is initialized as 1. Then we are checking whether I is less than or equal to n. Then I plus, that is I is increased. So inside the initial for loop, there is I is 1, that is the initialization. Then I is less than or equal to n, the condition checking, and I plus, the increment or the decrement operator. Then the codes, the block of code for that particular for loop starts here. So that is why this curly braces are there. Then the next for loop starts. For loop then j equal to 1, j less than or equal to 10, j plus plus. So in this case, j is compared with the 10. So j equal to 1, that is the initialization, then the comparison or condition checking, then the j plus plus, the increment of j. Then inside this for loop, there is only a single statement, and that is this one. That is print percentage d slash t I multiplied by j. So that is I and j, the product of I and j is displayed as a table here. So printf percentage d. So printf percentage d means the value of I into j will be displayed with the percentage d. This slash t represents a tab character. That is, once a particular value is printed, it leaves some space and then the next value is printed. So this is in order to read all these things. That is why we use this particular tab character. That is printf percentage d, then slash t, that is the tab character, then I into j. So I into j is the product of I and j is given. Then after this for loop, once this particular for loop is done, this j equal to 1, j equal to less than 10, j plus plus, once it is implemented, this printf slash n will be displayed, or that will be executed, that is slash n. The new line will be printed, or the new line character will be printed. So let us see how this particular program will execute. So we have to enter a value of n. So I am entering a value of 6. See what it has done. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, etc. So that is then 3, 6, 9. So on each row, the multiplication of 1, 2, 3, 4, 5, and 6 is being done. That is, in the first row represents the multiplication table for 1, the result of the multiplication table for 1. The second row gives the multiplication table for 2, the result of the multiplication table for 2. Then the third row gives you the result of the multiplication table for 3, etc. So how this is possible? In the first row, in this row, what happens is, let me take, so in this row, what happens is for I equal to 1, I less than or equal to n, I plus plus. So initially I equal to 1. Initially when we put I equal to 1, then we go to j. J equal to 1, j equal to less than or equal to 10, j plus plus. So then the values of j varies from 1, j equal to 1, j equal to 2, j equal to 3, up to j equal to 10 goes. J equal to 1 to 10 goes. So that is where this particular printf comes. So printf percentage d slash t. Percentage d is I into j. So I is 1. In all these cases, I is 1. And j varies from 1 to 10. So that is 1 into 1, 1 into 2, 1 into 3, 1 into 4, 1 into 5, 1 into 6, etc. up to 1 into 10. So when j is receives 10, j is 10, j equal to 10, j becomes equal to 10, this loop is also completed. That is, this loop for j is also completed. Then what happens is, this program exits from the for loop, from the j for loop, the loop for j. Then this particular statement comes into action, printf slash n, that is the new line is printed. So after this 10 here, after here we becomes, here it is 10, the new line is printed. So here we comes. So then the next loop, so for loop, the first for I equal to 1, we have executed only I equal to 1. So then next is I equal to 2. So in the next loop, I becomes 2. So then again, now I is 2, then this loop comes into action, this j loop, the loop for j comes into action. So inside this j loop again, the value of j varies from j equal to 1, 2, 3, etc. up to 10. So that is this case, 1 into 2 here. The second row in the output window, j equal to 1, I equal to 2 in all these cases, and j equal to 1, j equal to 2, j equal to 3, j equal to 4, etc. up to j equal to 10. So j equal to 10 means it is 20. So in the next loop, again it goes to the after the execution of this loop, this j loop, it again goes to the print /n. So 20, after 20, a new line character is printed. So that becomes takes the cursor to this 3, this position. Then I becomes 3. The next loop, I becomes 3, I becomes 4. In all these conditions, for I equal to 1, 2, 3 up to 6, the j value varies from 1 to 10. So that is how this table can be printed. So using this procedure, or using this multiple for loops, or nested for loops, you can create a two-dimensional structure, or a two-dimensional arrays, or an array of items. It can be, the array can be integers, or it can be any special characters like a star or a hash symbol, etc., etc. That is also possible. This is possible using the nested for loops. And back to our presentation. So we have seen the nested for loops also in this case. Today we discussed about the different types of for statement, that is the complex type of for statement, as well as the nested for statements, nested for loops, then the null, a for loop with a null statement, and a for loop with which is an infinite loop, etc., etc. And with that one, we end this session. Thank you.